Imagine for a moment a world where your entire digital office, your mission-critical applications, and your most sensitive data aren't physically housed within your building.
Right.
Instead, they exist as this sort of fluid digital entity accessible securely from, well, virtually anywhere on the planet.
Mm-hmm.
This, of course, is the cloud. And it's far more than just a passing tech trend. Did you know that by 2027, worldwide end-user spending on public cloud services is projected to soar past a monumental $1 trillion?
Wow, $1 trillion. That's huge.
It is. Yet here's the truly startling fact. Recent industry research reveals that for many organizations, cloud security is actually trending worse year over year.
Worse. That's concerning.
Exactly. What does this unprecedented scale of digital migration, coupled with a worrying decline in security posture, fundamentally mean for your career trajectory in information systems and cybersecurity? Today, we're embarking on a crucial exploration, drawing deep from Module 11 of the CompTIA Security Plus Guide to Network Security Fundamentals. Our mission is to immerse ourselves in the intricate landscape of cloud and virtualization security.
Yeah, it's a really important area.
Absolutely. We'll bridge the gap between foundational academic insights and the gritty realities of real-world applications, pulling from expert guides like those by BitWizards and David Mark Shaw, and even a fascinating Reddit AMA where Orca security researchers distilled insights from billions of cloud assets.
Oh, that Orca AMA was interesting. Some stark findings there.
Definitely. This isn't just about theory. It's about understanding the continuous cyclical process of analysis, implementation, evaluation, and maintenance of network and system security in these modern electronic data systems.
That continuous cycle is key: analysis, implementation, evaluation, maintenance. It never really stops.
Precisely. Our goal is to equip you, whether you're a BCIS 4345 student at Tarleton State University gearing up to make your mark, or an early career IT professional with the essential knowledge and practical takeaways for robust network defense and ethical hacking within these dynamic cloud environments, ensuring you're not just prepared, but poised for significant professional growth. Before we unpack this crucial topic, if you're finding these insights valuable for fortifying your career and staying ahead in our rapidly evolving tech world, please take a moment right now to like, subscribe, and share this deep dive.
Yeah, it really helps us get this information out there.
It does. Your support helps us bring more insider tips and knowledge directly to you. And as always, every additional resource we mention throughout our discussion is linked directly in the description below for your easy access. Okay, so from streaming movies to powering global businesses, the cloud is everywhere, yet it often remains this enigmatic, almost invisible force. Let's pull back the curtain and really understand what we're talking about when we say the cloud.
Good idea. It's often misunderstood.
At its most fundamental, the cloud simply refers to the internet and cloud computing. That's the act of utilizing computing hardware and software resources, not locally on your physical machine, but remotely over the internet. It represents a monumental shift from how businesses traditionally manage their IT infrastructure. Think about the traditional approach. You'd have physical on-premises computers, servers humming away in a dedicated data center you own, and individual workstations dotting your office.
The old server room closet, yeah.
Exactly. With cloud computing, you're utilizing that same equipment, but virtually, online, often without ever seeing the physical hardware. You might store your company's massive data sets on cloud storage, run your entire enterprise resource planning system on virtual servers hosted by a third party, or access specialized software through a web browser.
It fundamentally transforms the physical footprint of IT operations into a virtual one. No more racking and stacking servers yourself for the most part. And that transformation introduces a fascinating dichotomy, doesn't it? As an end user or even a business relying on cloud services, you're largely abstracted from the complex underlying infrastructure. Things like user management, machine virtualization, or even many aspects of physical security are handled by the cloud service provider.
Right. It's all behind the curtain.
Which sounds incredibly convenient, but for us as security professionals, it immediately begs a critical question. How does that shared responsibility model fundamentally redefine where our security duties begin and end?
That's the million-dollar question, isn't it?
It's not just a conundrum, it's the very core of cloud security strategy. You have to know who's responsible for what.
You've hit on the absolute crux of the matter. Because in this model, you're not owning the entire stack. Cloud service providers, or CSPs, are the ones who run and maintain the physical data centers, the servers, and the underlying virtual environments.
They're like the utility company for your digital infrastructure.
That's a great analogy. Typically, they operate on a subscription model. charging you for the access and usage of their services based on what you consume. It's a business model built on access and utility rather than outright ownership, and understanding that distinction is vital for anyone trying to secure these systems. It's easy to take the cloud for granted today, but its journey to ubiquity is actually a fascinating story of innovation born out of necessity. Wouldn't you just say that understanding where it came from really helps us grasp why it's so fundamental to modern security today?
Absolutely. You can't truly secure the cloud if you don't understand the foundational problems it was built to solve and the technologies that made it possible. It's like understanding the bedrock before you build a skyscraper.
Right.
The concept of computing as a public utility, much like electricity, was dreamed up by visionaries like John McCarthy way back in the 1960s. And while data centers for remote resource access have been around for decades, the real revolution and the security challenges that came with it emerged from a specific problem.
And that problem was largely rooted in inefficiency, wasn't it? For decades, especially after the PC revolution in the 1980s, businesses built their own server rooms, their own data centers.
Yeah, every company had one.
But by the late 1990s and early 2000s, with increasing internet speeds, these data centers were booming, consuming enormous amounts of energy. Yet, studies showed that most physical servers were vastly underutilized, often running at only 15–35% of their capacity.
Just sitting there, mostly idle.
Imagine all that power, all that cooling, all that physical space for resources mostly sitting idle. This wasn't just wasteful. It was a major bottleneck for scalability and cost.
Exactly. This underutilization was an unsustainable model, and that's where virtualization stepped in as the true game changer. In 2001, VMware introduced its ESX hypervisor.
Ah, the hypervisor. Key piece of tech.
Absolutely key. A hypervisor allows multiple instances of operating systems, each acting as a distinct virtual machine, or VM, to run simultaneously on a single physical server.
So one box doing the work of many.
Precisely. This was revolutionary because it decoupled software from hardware, allowing organizations to consolidate many underutilized physical servers onto far fewer, highly utilized physical machines. Suddenly, computing resources became significantly more affordable and efficient, directly paving the way for the cloud as we know it.
And building on that efficiency, once virtualization matured, the ability to rapidly provision and deprovision these virtual machines opened up entirely new business models. In 2006, Amazon Web Services, or AWS, launched its Elastic Compute Cloud.
EC2, that was a big one.
Huge. This was a paradigm shift. The ability to rent scalable computing resources, virtual servers, storage, databases from Amazon's vast data centers, and critically, pay only for what you used, often billed by the minute or second.
Pay as you go, it changed everything.
It democratized access to enterprise-grade computing power, making it available to startups and small businesses, not just corporate giants. And a huge, perhaps less obvious driver behind the cloud's dominance is what Brian Solis termed the Generation C effect. It fundamentally changed our relationship with technology, didn't it?
Absolutely. The C stands for connected. Think about it. Our smartphones are more powerful than PCs from a decade ago, and we're connected 24/7.
Always on.
Always. This constant seamless connectivity has fundamentally reshaped how we live, work, and interact with the digital world. From streaming our favorite shows on demand to mobile banking to using countless productivity apps, nearly all of these services operate on cloud computing.
We don't even think about it half the time.
Exactly. The cloud isn't just a business solution. It's an inherent, often invisible part of our daily lives, and that ubiquity makes securing it even more critical.
So given this incredible history and its pervasive presence, why the massive adoption? Why are nearly 94% of enterprises using cloud computing today? What makes it so compelling, driving end-user spending into the trillions? And what does that mean for how we approach network and system security? One of the most significant and immediate advantages is cost efficiency. Businesses can drastically reduce the need for physical on-premises hardware and the associated infrastructure.
Less hardware means less upfront cost, less power, less cooling.
Right. This slashes both capital expenditures, those big upfront costs of buying equipment, and operational expenditures, the ongoing costs of power, cooling, and maintenance. With a pay-as-you-go model, you only pay for the resources you actually consume, making IT costs predictable and scalable, which is invaluable for managing a budget and demonstrating return on investment. Then there's the sheer power of scalability and elasticity. This is absolutely crucial for modern businesses, especially those experiencing rapid growth or fluctuating demand.
Couldn't agree more. That flexibility is key.
Cloud computing allows you to easily adjust your resources, scaling up or down based on real-time needs. without the massive lead times and over-provisioning you'd need with physical hardware. Imagine a retail business during a Black Friday sale. They can spin up thousands of extra servers to handle massive traffic swings and then scale them back down just as quickly when demand returns to normal.
Instantly, almost. And that rapid elasticity isn't just about managing demand. It's a fundamental shift in how businesses can operate and how security professionals must plan. It means you're never paying for idle capacity, but always have the power you need when you need it.
Right, it's efficient.
From a security perspective, this speed also applies to deploying new security tools or isolating compromised environments. The ability to spin up a forensic analysis environment or a new, hardened application instance in minutes is a powerful defense mechanism. It's about building agility into your continuous process of analysis, implementation, evaluation, and maintenance.
That agility is critical for incident response. And that agility is further bolstered by flexibility and accessibility. With cloud computing, you can access data and applications from virtually anywhere with an internet connection.
Work from anywhere, basically.
Pretty much. This has fundamentally transformed the concept of work from a physical place to a set of activities you perform, supporting remote work, global collaboration, and greater employee mobility. For an ethical hacker, this distributed access also means new attack vectors to consider, requiring different approaches to penetration testing and vulnerability assessment. You can't just focus on the office network anymore. For overstretched IT teams, automatic updates and maintenance are game changers. Cloud providers shoulder the burden of managing software updates, applying security patches, and performing system upkeep on the underlying infrastructure.
Huge time saver. Patching is relentless work.
It really is. This offloads a huge amount of work from in-house IT departments, ensuring that systems are always up to date with the latest features and, crucially, the latest security patches. This directly impacts your ability to manage operations as the provider handles much of the baseline patching. Furthermore, robust disaster recovery and backup options are often built directly into cloud services. Many CSPs offer highly resilient data backup and recovery features, often with geo-redundancy, significantly enhancing data protection and minimizing downtime in case of localized failures.
Building that level of resilience yourself is incredibly expensive and complex.
Exactly. This level of business continuity and data integrity would be incredibly expensive and complex to build and maintain for most organizations on their own, especially for early career professionals learning to manage operations and respond to incidents. We also see vastly improved collaboration. Teams can work together in real time on shared documents and projects seamlessly, regardless of their physical location.
Like Google Docs or Microsoft 365, yeah.
This fosters productivity, breaks down geographical barriers, and supports a more dynamic working environment. This also means security professionals need to consider how to secure shared documents and collaborative platforms free from unauthorized access. Data leakage is a real risk there. Regarding security investments, it might surprise some, but major cloud providers invest astronomical amounts in security measures, protocols, and specialized talent.
They have huge security teams, resources most companies can only dream of.
Right. Often, they can offer far better, more sophisticated, and more resilient security than many individual organizations could ever afford to implement on their own, given their scale and specialized expertise. This means you, as a security professional, are building on a robust foundation, freeing you to focus on the in-the-cloud security aspects. And for sheer performance and reliability, leading cloud providers offer enterprise-grade levels of uptime and performance, frequently with multiple redundancies and global distribution to ensure continuous availability.
High availability is usually built in.
This means your applications and data are almost always accessible and performing optimally, which is critical for business operations and customer satisfaction. Finally, the cloud dramatically accelerates innovation. It provides easy, on-demand access to advanced technologies like artificial intelligence, machine learning, and big data analytics without the need for significant upfront investment in specialized hardware or software.
You can experiment with AML services without buying expensive GPUs.
Exactly. This democratizes cutting-edge technology for businesses of all sizes, allowing them to rapidly experiment and deploy innovative solutions. These benefits aren't just nice-to-haves, they're fundamentally transforming how we approach network and systems security. For you, whether you're a BCIS 4345 student or an early career information systems expert, understanding these drivers is paramount to comprehending the new security challenges and, critically, the new opportunities that emerge.
You have to understand the why before you can tackle the how of security.
Precisely. Grasping why businesses move to the cloud, directly informs your ability to analyze the risks involved and how to secure these complex systems effectively. This means focusing your knowledge on how cloud benefits shift and sometimes amplify risks, necessitating new approaches to securing systems, governance, and implementation. You'll need to understand how information, messaging, and database integrity are maintained in these distributed, multi-tenant environments.
And the unique aspects of physical security, or rather the lack of direct physical control you have.
Good point. And how risk analysis changes when your digital assets aren't under your direct roof. And of course, the ever-evolving and increasingly critical role of encryption in cloud data protection. In terms of skills, comprehending cloud scalability and disaster recovery isn't just abstract knowledge. It's vital for you to be able to implement and configure security measures effectively.
It ties directly into those course outcomes, right? Implementing security, conducting assessments.
Exactly. It directly applies to developing your ability to conduct comprehensive security assessments, manage operations in a dynamically changing cloud environment, and be prepared to monitor for and respond to incidents with agility. It's all part of that continuous process of analysis, implementation, evaluation, and maintenance that defines robust network and system security today. And with all these undeniable benefits, it's no wonder businesses are flocking to the cloud. But as we said earlier, it's definitely not a one-size-fits-all solution, is it?
Not at all. Businesses have to make some pretty fundamental choices about how they actually adopt it, and those choices have profound security implications.
Yeah, the how is critical.
Precisely. The how really dictates your security posture. You wouldn't build a house without choosing your foundation first, and cloud deployment models are essentially the foundation of your digital architecture. Each model carries a different shared responsibility matrix and distinct risk profiles that a security professional needs to deeply understand.
Let's dive into the deployment models, starting with the public cloud. This is arguably the most common method, and when most people refer to the cloud, they're often thinking of this model.
AWS, Azure, Google Cloud Platform, those are the big players.
Right. Here, computing resources, hardware, network facilities, software are owned and hosted by a third-party cloud service provider, or CSP. You and other users share the same underlying physical resources, but your accounts and data are logically, though not physically, separated. You typically access and manage your services via web browsers and dedicated apps. The advantages of public clouds are significant: low upfront costs, a flexible pay-as-you-go model where you only pay for what you consume, and virtually unlimited scalability. The CSP handles all hardware ownership and maintenance, which greatly reduces your operational burden.
It's fast and relatively easy to get started.
It is. It's often the lowest cost solution for general services like web-based email, hosted business applications, and online storage. However, there are inherent security considerations. You have less direct control over the shared underlying environment, relying heavily on the provider's security standards and performance.
That shared responsibility model really kicked in here. You secure your stuff in the cloud.
Exactly. There can be potential privacy and data law issues depending on where the data resides, and while initially low cost, it can become expensive over very long periods for extensive usage. Some also perceive it as inherently less secure due to the shared infrastructure, demanding meticulous configuration on your part. Next up, we have the private cloud. This is a cloud platform where every resource is reserved exclusively for a single organization.
So dedicated resources just for you.
Correct. This environment can be located on your company's premises, an on-premises private cloud, or hosted on an off-site dedicated facility by a third party. The critical distinction is the exclusive dedication of resources. If it's on-premises, your organization acquires and sets up all the necessary hardware and software, meaning you're also fully responsible for its maintenance, servicing, updating, and upgrading. The benefits here are substantial for specific use cases. You gain much more granular control and flexibility over customization, performance, and, crucially, security.
More control usually means better potential security if you manage it, right?
True. There's often a perceived and actual increase in security because the underlying physical and virtual resources aren't shared with external entities. It's still highly scalable within your dedicated resources. This model is particularly appealing to financial institutions, government agencies, and large corporations that handle highly sensitive data and must adhere to stringent security and compliance requirements.
Think banks, government, anyone with really tight regulations.
It's exactly. The trade-offs, however, include a much higher cost of establishment and ongoing running, continuous maintenance overhead, potential underutilization if not managed effectively, and the need for significant in-house IT and security skills to operate and maintain it. It's not cheap or easy. Moving into a blended approach, we find the hybrid cloud. This configuration is a strategic compromise, combining both public and private cloud environments.
Best of both worlds, potentially.
That's the idea. It's a complex but powerful model designed to leverage the best of both worlds. Data and applications can strategically reside on either the public or private cloud, allowing for tailored placement based on sensitivity, performance, or compliance needs. For instance, highly sensitive transactions or proprietary research might run securely within your private cloud, while high-volume, less sensitive applications or seasonal demand spikes can burst into the public cloud for additional capacity.
Cloud bursting. That's a classic hybrid use case.
It is. The advantages are clear. You get the scalability and cost efficiency of the public cloud, coupled with the enhanced control and security of the private cloud for critical data. However, the cons include complex service-level agreements, the challenge of aligning vendors, and ensuring compatibility between disparate cloud types.
Making everything talk to each other securely can be tricky.
Very tricky. And the inherent understanding that any elements running in the public cloud are still subject to its shared security considerations, demanding robust integration and consistent policy enforcement. And finally, there's multi-cloud. This is defined as an organization using cloud services from more than one cloud service provider, whether public or private.
So using AWS and Azure, for example.
Correct. Industry research consistently shows that nearly 90% of companies are now operating in a multi-cloud environment. The key benefit here is even greater flexibility, allowing you to choose best-of-breed services from different providers and a significantly reduced risk of vendor lock-in.
You're not tied to just one ecosystem.
Exactly. The primary consideration is that managing security, governance, and operational consistency across multiple distinct platforms can become incredibly costly and complex if not meticulously planned and automated.
Yeah, complexity is the enemy of security sometimes. Yeah. And that last point, managing security across multi-cloud environments, is perhaps the biggest challenge for an early career security professional. Understanding these deployment models isn't just about architectural diagrams, it's about discerning the ever-shifting security boundary. Who owns what responsibility in each scenario?
Knowing where your job starts and the provider's ends.
Precisely. And therefore, where your critical defense points and ethical hacking targets lie, each model fundamentally alters the shared responsibility matrix, and knowing that inside and out is absolutely foundational to designing and implementing effective defenses.
Okay, so once you've chosen your deployment model, public, private, hybrid, multi-cloud, the next layer of complexity and indeed security consideration comes in how you consume those cloud resources.
Right, the service models.
Exactly. This varies widely, from renting raw infrastructure to simply using a fully managed application. These are called service models, and they represent different levels of abstraction that directly impact your security responsibilities. The most fundamental service model is infrastructure as a service, or IaaS. This provides virtualized computing infrastructure over the internet, essentially giving you access to virtual servers, storage, processing power, and network facilities.
Basically renting the hardware virtually.
That's a good way to put it. With IaaS, the service provider owns and operates the physical infrastructure, but you manage the operating systems, middleware, and applications that run on top of it. It's akin to accessing a virtual machine online that you then configure to your exact specifications.
To use a familiar analogy, think of IaaS like buying pre-packed ingredients and a sauce from the grocery store. You still cook at home, you prepare the meal, but someone else handled the basics like growing the vegetables and making the pasta.
You're still doing the cooking.
You're responsible for the final dish. It's similar to accessing a virtual machine online where you configure the operating system and applications. Businesses often use IaaS as a highly scalable, inexpensive alternative to on-premises servers for cloud storage, data backup, or hosting websites and applications, especially those with vast volumes of data. For a security professional, this means you own the security of the operating system and above, while the provider handles the below-the-OS security.
Moving up the stack, we have Platforms as a Service, or PaaS. This is a bit more specialized than IaaS. PaaS provides not just the underlying resources, but also the entire environment needed to develop, manage, test, run, and update software applications.
So it includes the OS, databases, development tools.
Yeah. Exactly. The operating systems, middleware, database management systems, and software development tools. The provider completely abstracts away the underlying infrastructure management, freeing developers to focus purely on writing and deploying their application logic. So, extending our analogy, if IaaS is the pre-packed meal kit, PaaS is like ordering takeout. The meal is prepared for you from ingredients to cooking, but you still need to set the table, serve it, and clean up afterward.
Okay, I like that. You handle the application code itself, but the platform is managed.
Right. PIAS is ideal for businesses deeply involved in software development and testing, resource-intensive analytics tools, enterprise resource planning, ERPs, and hosted communication systems like VuVP. It significantly cuts down coding time and speeds up software development by removing the need to install and configure complex development support structures. From a security standpoint, the shared responsibility shifts significantly. You're securing your application, while the platform and infrastructure layers are the provider's domain.
Then, at the highest level of abstraction, we have software as a service, or SaaS. This is by far the most familiar model for most people in their daily lives. SaaS refers to a fully functional software application distributed and purchased on a subscription basis over the internet.
Like Office 365, Salesforce, Gmail.
Exactly. You're simply renting and using an end-user application. The vendor takes care of the software's entire hosting environment, the underlying servers, operating systems, and runtimes. You generally cannot access anything below the application's user interface. You just interact with the application itself. SaaS is the ultimate convenience. It's like calling ahead to a restaurant, ordering your meal, and just showing up to eat. Think Gmail, Salesforce, or Dropbox. These are ready-to-use applications, fully managed and maintained by the cloud service provider.
Super convenient.
They're typically web-based, accessible from any internet-enabled device, and offer a much lower cost for high-end enterprise software, promoting significant workplace mobility. For security, your primary responsibility shifts to securing access to the application itself, strong user authentication, proper authorization, and monitoring user behavior within the application. The provider handles everything else related to the infrastructure and application code.
And a relatively new player, rapidly gaining traction and evolving the landscape, is serverless computing, also sometimes referred to as function as a service, or FACE.
FASE, yeah, like AWS Lambda or Azure Functions.
Right. This model allows you to build applications as simple event-triggered functions without you, the user, managing or scaling any infrastructure whatsoever. The cloud provider dynamically allocates and manages the servers only when your code needs to execute, and then deallocates them. And serverless. That truly is going out to a restaurant, ordering pasta, and the restaurant handles everything from sourcing ingredients to hiring staff to cooking to ensuring it's ready without you waiting or managing anything.
You just eat the pasta and pay for what you ate.
Exactly.
Yeah.
You literally just pay for a pasta you eat. You pay only when your code is executing, and not a moment more. It's an incredibly hands-off approach to infrastructure management, but for a security professional, it means securing the code itself and the event triggers, rather than worrying about the underlying server. And beyond these core three, there's the broader concept of anything as a service, or ZES. This term encompasses a wide range of specialized cloud services that continue to emerge, like database as a service, DBAS, security as a service, SECA, or artificial intelligence as a service, AIS.
Basically anything you can imagine delivered as a service.
Pretty much. It highlights the growing trend of consuming virtually any IT functionality as a cloud-delivered, subscription-based service, pushing the boundaries of what's possible in cloud security. Okay, this brings us squarely to the core of our exploration. How do we effectively secure all this virtual infrastructure and the sensitive data it holds? The cloud, while offering immense benefits, introduces a genuinely unique security landscape, one distinct from traditional on-premises environments.
Yeah, the old rules don't always apply in the same way.
It's no longer just about firewalls on a physical network. It demands a more nuanced and adaptive approach to network defense. First, let's examine the specialized cloud-based security controls that have emerged. We're talking about virtual security appliances here, not physical boxes you rack and stack.
Software-defined security, basically.
Exactly. These include cloud-native firewalls and secure web gateways, SWGs, which provide essential security functionalities within these virtualized environments. They act much like their physical counterparts, but are entirely software-defined, cloud-native, and can scale dynamically with your cloud resources. Another absolutely critical control, especially when dealing with software as a service, SaaS applications, is a Cloud Access Security Broker, or CASB.
CSBs are huge now. Very important.
You really are. A CASB acts as an intelligent control point positioned between your cloud users and the cloud service providers. Its role is multifaceted, enforcing security policies across various cloud apps, providing deep visibility and granular control over cloud usage, and robustly protecting your data through features like data loss prevention, DLP, encryption, and sophisticated access controls.
It's like a security gateway specifically for cloud apps.
Think of it as a highly sophisticated traffic cop and customs agent for all your cloud interactions. For you, as an ethical hacker, understanding how CSB's enforced policies can inform your attack strategies. And then there's Secure Access Service Edge, or SES, pronounced SASE. This isn't a product, but a comprehensive architectural framework that converges networking and security functionalities into a single, cloud-delivered service model.
SaaS combines network and security. Things like SD-WAN, firewall, zero trust.
Exactly. It integrates elements like secure web gateways, firewall as a service, and zero trust network access into a unified platform.
SaaS is a crucial shift, especially for early career professionals to grasp. It simplifies architecture and integrates security, which is absolutely vital for managing security across increasingly distributed and mobile cloud environments.
Instead of juggling lots of different security boxes or VMs.
Right. Instead of stitching together disparate security products, SES offers a unified cloud-native approach that's perfectly suited for organizations with a remote workforce and a heavy reliance on cloud applications. It's about bringing security closer to the user and the data, wherever they happen to be, fundamentally enhancing your ability to implement security measures consistently across a dynamic perimeter.
Now, despite these powerful controls, the cloud also introduces a distinct set of cloud vulnerabilities that demand our constant vigilance. A major one, and a persistent headache for security teams, is responsibility matrix confusion.
Yes, the who's responsible for what problem again.
It keeps coming up. This arises from a fundamental misunderstanding or misalignment of security duties between CSPs and their users. This is a monumental point for any aspiring security professional. The cloud operates on a shared responsibility model. The provider secures the cloud itself, the underlying infrastructure, the physical data centers. But you, the customer, are responsible for security in the cloud, your data, your applications, and crucially, your configurations.
If you misconfigure something, that's on you, not the provider.
Exactly. If you don't clearly understand these precise boundaries, that ambiguity immediately becomes a gaping security hole, just waiting to be exploited. It's like leasing an apartment. The landlord maintains the building structure, but you're responsible for locking your door and deciding who gets a key. Another significant vulnerability stems from a pervasive lack of cloud conceptual model within organizations. Many leadership teams, eager to reap the benefits, rush to the cloud without fully grasping its unique environment, its idiosyncrasies, and its architectural differences from on-premises systems.
They treat it just like their old data center, which leads to mistakes.
Precisely. This often leads to glaring misconfigurations, insecure API endpoints, and inadequate access controls, simply because the team responsible doesn't fully understand the new digital landscape they're operating within. It's akin to trying to navigate a complex new city without a proper map or understanding of its traffic laws. We also encounter resource reuse as a specific virtualization vulnerability. In a multi-tenant environment, if physical resources like memory or storage blocks are not properly sanitized or emptied after a virtual machine is decommissioned or moved.
Data from one customer could potentially leak to another.
Exactly. Sensitive data from a previous tenant could potentially be exposed to another VM sharing that physical hardware. This is a subtle but potentially serious data integrity risk that cloud providers must mitigate and you, as an auditor, should be aware of. And a particularly insidious threat is VM escape, where a virtual machine manages to break out of the contained virtual environment and directly interact with or compromise the host operating system, the hypervisor itself.
That's the nightmare scenario for a cloud provider.
It really is. This could grant an attacker control over the underlying physical server and, terrifyingly, potentially other VMs residing on that same host. While rare, it's a testament to the advanced threat that can target the foundational layers of cloud infrastructure. So how do we, as ethical hackers and network defenders, strategically address these unique vulnerabilities? Let's discuss some absolutely critical security controls and best practices. First and foremost, conduct regular audits.
You have to check your work, continuously evaluate.
Absolutely. These are essential to evaluate the effectiveness of your cloud security controls. You should leverage established frameworks like the Cloud Security Alliance, CSA, Cloud Controls Matrix, or the National Institute of Standards and Technology, NIST, cybersecurity framework. These frameworks provide comprehensive guidance on what to check, from data security and encryption to access controls and incident response capabilities, forming a critical part of your continuous evaluation process. Next, a fundamental architectural control. Use regions and zones. Major cloud providers like AWS organize their infrastructure into geographically separated data centers called regions, and within each region, they offer multiple isolated availability zones, or AZs.
Spreading your resources across AZs gives you high availability.
Exactly. Distributing your workloads across these separate AZs and regions significantly enhances fault tolerance, provides robust disaster recovery capabilities, and helps address critical data sovereignty requirements by allowing you to choose where your data physically resides. If one zone goes down, your application can seamlessly fail over to another, ensuring continuous availability and resilience against widespread outages.
This multi-AZ and multi-region design isn't just about ensuring uptime. It's a fundamental security control against widespread outages and regional threats. By isolating your infrastructure across these distinct physical locations, you create a far more resilient and secure environment.
Protecting against floods, power outages, things like that.
Right, protecting against everything from localized power outages and network failures to natural disasters or even targeted regional attacks. For you, as an architect or auditor, understanding where data lives and how it's replicated is paramount for risk analysis and ensuring data integrity.
Crucially, implement secrets management. This involves the secure storage, robust access controls, and regular rotation of all sensitive information. Your secrets like passwords, API keys, database credentials, and encryption keys.
Don't hard-code secrets in your applications, please.
Yes, please don't. Tools like AWS Secrets Manager or HashiCorp Vault help you manage these secrets in secure, centralized vaults, drastically reducing the risk of hard-coding them into applications or exposing them through insecure means. This is a core component of securing systems and maintaining data integrity. We also need to vigorously enforce functional area mitigations. This means applying specific, tailored security controls to different functional areas within your cloud environment. For network security, that translates to stringent network segmentation.
Things like VPCs, security groups, network ACLs.
Exactly. Think virtual private clouds, VPCs, to logically isolate your production environment from development, or granular security groups and network access control lists, ACLs, to control traffic flow between different application tiers, ensuring your database can't talk directly to the internet, for instance. For data security, strong encryption policies are non-negotiable, both at rest and in transit. And for identity and access management, robust multi-factor authentication, least privilege access, and regular access reviews are absolutely essential. Finally, for organizations leveraging hybrid cloud environments, there are specific considerations. It is paramount to establish consistent security policies, unified identity management, and secure encrypted connectivity between your on-premises infrastructure and your public or private cloud services.
Making sure security is seamless across both environments.
Right. This ensures a seamless and secure operational boundary, often utilizing solutions like hybrid cloud firewalls, dedicated network links, or cloud access gateways to maintain integrity and control across disparate environments. Okay, so if we're building and managing so much in the cloud and doing it at scale, how do we ensure it's done efficiently, consistently, and most importantly, securely?
That's where automation comes in.
Exactly. That's where infrastructure as code, or IAC, comes in. This isn't just a development trend. For us in security, it's rapidly becoming an imperative. What exactly is IAC? In simple terms, IAC means using code to define and provision your infrastructure. Instead of manually clicking through a cloud provider's console to set up servers, networks, or databases, you write a descriptive model of your desired infrastructure in code.
Like a blueprint, but written in code.
Perfect analogy. This code then becomes an integral part of your project, stored in a version control system, often abbreviated as VCS, like Git, right alongside your application code. This ensures your infrastructure is managed with the same rigor and meticulousness as your software. The benefits of IAC are numerous, and many directly translate into significant security advantages. First, consider repeatability and consistency. IAC virtually eliminates the human error that inevitably creeps into manual configurations.
No more, oops, I forgot to check that box errors.
Right. When you deploy the same code, you get the exact same environment every single time. This ensures no discrepancies or accidental security misconfigurations across your production, staging, and development environments, which is critical for maintaining integrity across your systems.
And for security, that consistency isn't just about efficiency. It's your primary defense against configuration drift, those subtle, manual changes that often introduce new vulnerabilities unnoticed.
Drift is a huge problem.
It really is. IAC forces discipline, making your infrastructure auditable and predictable. A security dream if you get it right. It's a powerful tool for your continuous evaluation process.
Then there's change management and version control. Because your entire infrastructure is defined in code and stored in a version control system, every single change is tracked. You know precisely who made what change, when, and most importantly, why.
That audit trail is invaluable for compliance and forensics.
Absolutely. This provides an invaluable audit trail for governance, compliance, and post-incident analysis. Plus, it enables incredibly easy and reliable rollbacks to previous known good secure states if something goes wrong, a lifesaver in incident response.
If we look at the bigger picture, version control is no longer just for application developers. It's a critical security tool, giving you an immutable record of infrastructure changes and who made them.
It's infrastructure history, essentially.
Exactly. This level of transparency is absolutely essential for forensic analysis, maintaining a strong security posture and ensuring accountability in a distributed cloud environment. For ethical hacking, this provides an attack path for understanding misconfigurations or backdoors introduced via code.
IAC also provides powerful environment drift detection. When used with a declarative approach, which we'll discuss in a moment, it can automatically detect and even correct manual changes made outside of the defined code.
So it can fix things that people change manually on the side?
Correct. This actively prevents configuration drift, where a manually altered setting could inadvertently introduce a security vulnerability that goes unnoticed. The system can simply revert it to the desired state defined in your code, enforcing your security baseline. Another key concept that makes IAC so reliable is idempotence. This means that applying your IAC code multiple times will always yield the exact same desired result.
You can run it again and again and it won't break anything or make unexpected changes.
Precisely. You can run your IAC code repeatedly, and it will ensure that the desired state is consistently met without unintended side effects or configuration changes where none are expected. This predictability is golden for security, ensuring your hardened configurations remain hardened. And finally, CI/CD integration. Infrastructure as code can be seamlessly integrated into your continuous deployment pipelines.
Automating infrastructure changes just like application code changes.
Right. This automates secure infrastructure deployments, allowing you to test applications in production-like environments much earlier in the development lifecycle, effectively shifting security left. This means catching security issues and misconfigurations in code before they ever hit live systems, dramatically reducing your attack surface. Of course, the challenges of IAC adoption are real. There's a significant learning curve, especially for traditional infrastructure teams who might not be familiar with version control systems, using Git, or comfortable with code editing tools.
It's a different skill set, moving from clicking buttons to writing code.
It really is. It fundamentally requires new skills, and finding staff already proficient in IAC and DevOps practices can be difficult given the high demand. It's an investment in training and time, but one that pays significant security dividends over the long term. When it comes to how you write your IAC, there are two main philosophical approaches: declarative versus imperative. Declarative is the most popular and dominant approach today. Here, you simply define the desired end state of your infrastructure.
You say what you want, not how to get there.
Exactly. The tool then intelligently figures out how to achieve that state, handling all the complex step-by-step executions behind the scenes. Tools like Terraform, Bicep, and CloudFormation predominantly use this. They are particularly useful for updates and changes because they're inherently idempotent. You define what you want, and the tool makes it so. In contrast, with an imperative approach, you meticulously define the steps to execute to reach the desired solution.
Like writing a script with commands.
Right. This gives you more granular control over the process, but it may not be idempotent, meaning the end result could differ depending on the starting point or if steps are skipped. Tools like Chef and AWS Cloud Development Kit, CDK, often lean more imperative. For a security professional, declarative approaches generally lead to more consistent, auditable, and thus more secure environments. Now let's quickly touch on some of the key IAC tooling out there and how they stack up with security in mind. Terraform is a declarative tool that uses its own HashiCorp configuration language, or HCL, which is known for being relatively human-readable.
Terraform is hugely popular, probably the most well-known.
Definitely. Its major strength is its multi-cloud capability, meaning you can use it to provision infrastructure across almost any cloud provider, and even on-premises systems. This consistency across diverse environments is a huge security benefit for managing a holistic posture. However, Terraform maintains a state file, which describes the existing infrastructure.
Ah, the state file. That needs careful handling.
It really does. Securing this state file, which can contain sensitive information, is absolutely crucial, requiring careful management and encryption. OpenTofu is a significant open-source fork of Terraform, aiming to be a truly community-driven project that will expand on Terraform's concepts.
Born out of the licensing changes with Terraform, right?
Exactly. It was forked from Terraform version 1.5.6, so it starts with all those existing features. The community will dictate its direction with plans for features like state encryption, which directly addresses a key security consideration of Terraform. It's designed to be a drop-in replacement, working seamlessly with existing Terraform state files. Then there's Pulumi, another declarative IAC tool. What sets Pulumi apart is that it allows teams to use familiar general-purpose programming languages like Python, Go, C# or JavaScript to define their infrastructure.
So developers can use languages they already know well.
Right, which can be highly desirable if your team already has strong coding skills in one of these languages. Like Terraform, it's multi-cloud and excellent for integrating with existing code testing tools, which, again, is a major security advantage because you can apply your standard code testing rigor to your infrastructure definitions, catching errors early. For Microsoft Azure users, you have native tools. Azure ARM templates, written in JSON, are the native templating option. While they're well documented and fully supported, they can be quite verbose, requiring a lot of boilerplate code.
ARM templates can get really long and complex to read.
They really can, making them complex and prone to syntax errors and misconfigurations. They also lack an explicit state concept, meaning changes can sometimes be destructive, and there's no dry run option to see precisely what changes will occur before applying them. This makes secure change management more difficult. To simplify this, Microsoft developed BICEP, a domain-specific language that abstracts away much of the JSON boilerplate, offering cleaner, more concise code.
BICEP is much nicer to work with than raw ARM, in my opinion.
I agree. BICEP can query the state directly from Azure, so it doesn't require a state file, which is a significant advantage over Terraform from a state management security perspective, eliminating a common attack surface. On the AWS side, AWS CloudFormation is their native IEC tool, using a declarative approach with JSON or YAML. It's a fully managed AWS service that continuously checks the infrastructure to detect if it's maintaining the described state, similar to BICEP.
So also no separate state file to manage.
Correct. No external state management is required on your part. And for those who prefer programming languages, the AWS Cloud Development Kit, or CDK, allows you to define cloud resources using familiar languages like Python or TypeScript, generally taking an imperative approach. Finally, we have traditional configuration management tools like Ansible, Salt, Chef, and Puppet. While primarily used for managing software configurations on servers, they also possess capabilities for infrastructure provisioning.
They sort of blur the line between config management and provisioning sometimes.
They do. Puppet is declarative, Chef is imperative, and Ansible and Salt offer a mix of both. These are excellent for maintaining the desired state of individual servers within your cloud environment, complementing ISE tools for overarching infrastructure. So what does this all mean for you as a future security professional, whether you're analyzing systems for vulnerabilities or implementing robust defenses? Understanding IEC means you can not only build secure infrastructure definitions, but also proactively identify misconfigurations and vulnerabilities in code before they become real-world threats.
Finding problems in the blueprint stage, not after the house is built.
Exactly. It's about fundamentally shifting security left in the development lifecycle. This ties directly into your continuous process of analysis, implementation, evaluation, and maintenance of network and system security, making it a more automated, consistent, and therefore more secure process. You're not just securing systems, you're securing the very definitions of those systems, making you an invaluable asset in any modern IT organization. Okay, we've been discussing how cloud security is alarmingly trending worse.
Yeah.
But what does that actually look like on the ground, in the trenches of real-world cloud environments?
Yeah, let's get into those Orca's security findings you mentioned earlier.
Right. Some genuinely fascinating, albeit stark, insights come from that Reddit AMA with Orca security researchers. These experts analyzed billions of cloud assets across the major providers, AWS, Azure, Google Cloud, Oracle, and Alibaba Cloud. And their findings are, frankly, a bit of a wake-up call for our industry. The overall trend they observed is deeply concerning. Cloud security for organizations is sadly trending worse than it was just last year.
Worse. Despite all the talk and investment, that's sobering.
It really is. This is a critical insight, indicating that despite increased investment and growing awareness, we are actually losing ground in some fundamental areas. It means the challenge for skilled cybersecurity professionals like you is only intensifying. One of the most striking findings was what they termed the attack path problem. The researchers discovered that a surprising 13% of organizations have at least one cloud asset responsible for creating more than 1,000 potential attack paths.
1,000 paths from a single asset. Wow.
Think about that for a moment. A single misconfigured server, an unpatched application, or an overly permissive identity and access management (IAM) role could inadvertently provide over 1,000 different routes for an attacker to reach sensitive data or critical systems.
What's truly unsettling here is the outsized impact a single misconfigured asset can have. This immediately raises a critical question for any security analyst. How do we effectively prioritize and understand these complex, interconnected risks?
You can't fix everything at once, you have to prioritize.
Exactly. It's not enough to simply know a vulnerability exists. You need to understand its context within your entire environment and, for an ethical hacker, how it can be chained with other weaknesses. This moves beyond simple vulnerability scanning into true attack path analysis.
Exactly. And the Orca researchers highlighted key factors for precisely prioritizing risks. You need to consider reachability. Can an attacker actually exploit this vulnerability from their current position?
Is the door actually unlocked and accessible?
Right. For instance, if a vulnerability requires a specific port to be open for exploitation, but that port is meticulously firewalled off, the immediate exploitability is lower, even if the vulnerability still technically exists on the asset. Then there's attack path analysis. Is the risk part of a logical path that leads directly to a crown jewel? A crown jewel could be your organization's most sensitive customer information, a critical database holding proprietary intellectual property,
Right.
or broad administrative access that could lead to a full compromise.
Does this vulnerability lead somewhere truly damaging?
Precisely. A vulnerability that is part of an active attack path leading to such a high-value asset is exponentially more critical than one that leads nowhere important or to trivial data. This is crucial for your risk analysis skills. And finally, context matters immensely. You need to consider the potential impact of exploitation, how easily the risk can be abused, whether it acts as an entry point from the outside world or is only exploitable by someone already inside the environment.
And even the return on investment, or ROI, how much effort it would take to fix versus how much more secure the organization would truly become.
Right. These variables are vital for separating the truly dangerous high-priority risks from the less critical ones, informing your incident response and management operations. Another significant finding from the report was the proliferation of neglected assets. These are cloud assets that haven't been updated, patched, or even used for a long time.
The digital equivalent of dusty boxes in the attic.
Good analogy. They represent a significantly larger attack surface because they're far more likely to have known unpatched vulnerabilities, or they can become shadow assets, assets within your environment that you're simply not aware of and therefore not actively securing. This digital cruft poses a substantial and often overlooked threat, providing easy targets for attackers. So if there's one thing you should take away from this critical report for your own studies, your BCIS 4345 coursework, or your early career, what is it? What are those most fundamental weaknesses in the cloud right now, the ones that genuinely keep security professionals up at night?
Well, if I had to pick two things that consistently keep me up at night and are the most significant yet often overlooked weaknesses, it would have to be patching and robust network security.
Back to basics almost.
It really is. Just like a daily vitamin regimen keeps you healthy, consistent patching is the foundational defense against the vast majority of known vulnerabilities that attackers frequently exploit. It's the simplest yet most effective way to prevent a lot of pain down the road.
Patch early, patch often.
Absolutely. And strong network security, and I mean really strong, with proper segmentation, least privilege access controls, and vigilant monitoring is your absolute first line of defense. It makes it exponentially harder for attackers to gain a foothold or to move laterally once they're in. Keep these two fundamental principles in check, and you, as an ethical hacker or a network defender, can save yourself and your organization a tremendous amount of pain down the road. They are fundamental, but often the most basic things are the ones that are overlooked in complex cloud environments.
That's incredibly practical and actionable advice. And for you, the listener, these insights directly inform your ability to develop vital skills. This means knowing how to conduct effective security assessments in a cloud environment, how to manage operations with these critical vulnerabilities in mind.
And how to proactively monitor for and rapidly respond to incidents, prioritizing effectively based on attack path analysis and contextual risk.
Exactly. It's all about building a proactive, resilient defense in a world that increasingly relies on the cloud. Wow, what an insightful discussion. We started our deep dive by exploring the very definition and dynamic history of cloud computing, from John McCarthy's early vision of computing as a utility to the game-changing power of virtualization and the rise of Amazon Web Services.
Now, covered a lot of ground from the 60s to today.
We really did. We then unpacked the incredible benefits the cloud offers, from unparalleled cost efficiency to rapid scalability, which are driving its massive adoption across every sector. But as we learned, this convenience and power come with significant and often misunderstood security responsibilities.
That shared responsibility piece is just so crucial.
Absolutely. We navigated the different deployment models, public, private, hybrid, and multi-cloud, and broke down the service models, IaaS, PaaS, and SaaS, even dipping into serverless, using relatable analogies like ordering pasta.
The pasta analogy seemed to work.
I thought so too. Most importantly, we connected all of this to the critical issues of cloud and virtualization security, identifying common vulnerabilities like responsibility matrix confusion and VM escape, and discussing essential controls, including the transformative power and security implications of infrastructure as code.
And the importance of patching and network security highlighted by that Orca report.
Right. We ended with a stark reminder from the Orca security report. Cloud security is trending worse, making fundamental defenses like consistent patching and strong network security more vital than ever for your career in information systems.
This exploration into cloud and virtualization security isn't just academic. It's absolutely preparing you for the front line of modern IT. Your understanding of these inherent risks, the best practices, and innovative solutions like ISC will be invaluable as you learn to implement and evaluate security measures, manage operations, and respond to incidents in your future roles.
It's practical knowledge you can use right away.
Exactly. Whether you're a BCIS 4345 student building your foundational knowledge at Tarleton State University or an early career professional navigating complex cloud environments, you are truly at the forefront of a dynamic and critical field, helping to secure the electronic data systems that power our interconnected world.
And if you found this deep dive insightful, make sure to like, subscribe, and share it with your network. Don't miss out on future explorations that can protect and advance your career.
And check out those links in the description. Lots of good resources there.
Definitely. You'll find links to all the resources we discussed, including the CompTIA Security Plus guide, in the description below. As you reflect on today's deep dive, consider this. With cloud computing becoming so ubiquitous and intertwined with our daily lives and business operations, how will the increasing complexity of multi-cloud and hybrid environments challenge the very definition of security boundaries? And what new roles will emerge to bridge those gaps?
Something to think about for sure. The landscape is constantly changing.
Stay connected, stay secure. Until next time, keep your network strong, your data protected, and your curiosity alive.